Because basically what happens, they cancel each other out, right? The effect of addition and subtraction if you apply, okay. So you call subtraction the inverse operation of addition, based on the inverse operation of multiplication. Well, anti-differentiation, or the other popular term is integration. The other term for anti-differentiation. Integration is the inverse operation of differentiation. Okay? So, if you are being asked to anti-differentiate, for example, what's the derivative of x squared? What's the derivative of x squared?
2x.
Okay, right? Okay, 2x. So, 2x, right? The derivative, 2x. Now, suppose I ask you, find the antiderivative of 2x. What do I actually mean by finding the antiderivative of 2x? I am actually looking for a function whose derivative is 2x. Okay, that's what you mean by antiderivative. So I am looking for a function whose derivative is 2x. If I say solve or look for the antiderivative of 2x, it means you find a function whose derivative is 2x. And what would be an obvious answer? X squared, right? Okay, we started with the x squared. But, sir, why do I see a plus c in the answer? Okay, when I get the antiderivative, right? A plus c. The c that you see there is called the arbitrary constant of integration. Now, why is that the case? Okay. I agree with you to tell me that x squared is an antiderivative of 2x. Because if I get the derivative of x squared, it's going to be 2x. So therefore, x squared is an antiderivative of 2x. But unlike derivative, I can actually have more than one antiderivative for a given function. Now, for instance, would you agree with me if I say x squared plus 1 is also an antiderivative of 2x? Yes, because the derivative of x squared plus 1 is also 2x. X squared minus 3 is also an antiderivative of 2x. Because again, if I differentiate x squared minus 3, I also get 2x. Now, so that you don't have to enumerate all the possible antiderivatives of 2x one by one. That is why you have the plus c. The plus c takes care of all the possible antiderivatives of 2x. Kasi, di ba? Whatever constant you plug in to c, it will be an antiderivative of 2x. Because remember, the derivative of a constant is 0. So, whatever I put in here, okay, then you have, it's going to have the same derivative, which is 2x. So, the notation that's used by the book, actually I didn't know, because what is inverse operation? The one notation that they use is actually d and then to the negative one expression. I think that's the one expression that they use. So, 2x, the answer is x squared plus c. The other notation that they use is the one with an integral sign. Okay, the one that uses an integral sign. And then you put the function, but the integral sign always goes with this expression dx. So it's 2x dx. The answer is, of course, the same. X squared plus c. Good. Now, how do I now get the derivative for how do I get the antiderivative now in general? So 2x is very easy. I can think of it x squared right away. But what about for more general expressions? Are there rules actually that you follow similar to differentiation? Well, there's just one basic rule that you remember. This one. The integral. Well, maybe one and another one after. But the most important one is this. The integral of x to the n, right, is n, it's x to the n plus 1 over n plus 1 plus c. Okay? Integral of x to the n dx is x to the n plus 1 over n plus 1. Okay. Example. What is the antiderivative for x cubed? What is your n here? 3. Okay. So we have x raised to 4 over 4, and then don't forget your answer. Now, how do you check if your antiderivative is correct?
Find the derivative.
Get the derivative of your answer. What you should get is the given. If I differentiate x to the 4 over 4, I will get x here. In constant, I will just copy, then x to the 4 becomes 4x cubed, 4 cancel. And why do you need the plus c? Because I want to capture all the possible antiderivative. Because I can have x to the 4 over 4 plus 1, plus 2, minus 5, etc. Okay. Now,
Sir, what about the in number 14? There's an integral sign and then there's a number.
I'll get to that. I'll get to that.
Yung two numbers.
Let's finish up your stop work. Okay. Yeah. Okay. Now, okay. What about if I have a constant? Let me use a different variable. If I have a constant that I'm trying to differentiate. So, the variable is x, but what I have is a constant. What would be the antiderivative? The antiderivative is going to be ax plus c. Why is it like that? Well, remember I don't have an x in the integral, which means that it's 1, right? Correct? But if you have 1, I can write that as x to the 0. And if I apply this rule, if I have x to the 0, if I apply this rule, what do they do? Divides x to the 1 over 1. So there's a constant to multiply. For instance, what's the antiderivative of 2?
0. No. 2x.
2x. Are you sure it's correct? Well, what's the derivative of 2x? What's the derivative of 2x? 2. That's how I'll actually check what's the correct antiderivative. Okay. Now, what if I have 2 terms? What about if I have 4x? What's the antiderivative? So I copy 4, this is a constant, then I apply this rule, x squared. But because we can simplify it, of course we want to simplify it. That's 2x squared. Sabihin natin para sa derivative. Suppose I want to get the derivative of 3x squared minus 8x plus 5. Let's get the antiderivative 1 by 1. 3x squared, I will copy 3, have 3. And then what is the antiderivative of x squared? X cubed. Okay, x cubed over 3. Minus 8. Okay, then x, what is the derivative of, what is the antiderivative of x? X squared over 2. Okay, just using this, right? And then plus 5, I copy 5. What is the antiderivative? 5x. Now, I'm done with the antiderivative, but there are other possible antiderivatives by adding or subtracting a constant, right? So, to capture all those possibilities, right? Yes. And then, of course, do the arithmetic to simplify the final answer. Okay. 3 cancels, so I have x cubed. Okay. Now, let me answer that question. What about those that you take derivative, there's a number before the symbol and after the symbol? Okay. First of all, that expression is called a definite integral. Okay. Ayan. We call it a definite integral, this expression. Okay. Now, because you see the integral sign, that means the one that looks like a letter S, it's called an integral sign. It means the operation is anti-differentiation or integration. Okay, the operation is anti-differentiation or integration. Now, to solve this, what I will do, okay, is to look for an antiderivative. Say, integration, antiderivative. Look for an antiderivative of small f. Let's say big F is its antiderivative. Okay? Now, first, you have a plus C. But when I solve a definite